Hey guys, Mr. Horszewski again, and in this video I'm going to give you a couple of examples dealing with the difference of two squares formula, or in other words, how we factor a difference of two squares. Let's dive right into it. The first example I'm going to give you is going to be the expression x squared minus 9. Alright, first notice that it's a binomial and we have two terms that are being subtracted. Also notice that there's no GCF between them, so we don't have to worry about pulling out a GCF before proceeding. One sign that you might need to factor this using a difference of two squares formula is the fact that we have x squared. Now what would be nice is if we could figure out a number that gives us 9 once that number is squared, and I'm sure we have an idea of what that is. That would be 3. So I'm going to do a little bit of rewriting here. I'm going to put x in parentheses because when you square x you get, well, x squared. I'm going to do a similar thing with 9. I'm going to write a set of parentheses squared, and then as we noted a second ago, what gives us 9 after we square it is the number 3. Doing it this way allows you to see quite clearly what expression you're going to use for a, in which case that's x, and what expression you're going to use for b, and in this case that's going to be 3. Now remember, the difference of two squares formula, what you're going to do is set up two sets of parentheses. And in your first set of parentheses, you're going to write the expression a plus b. Well, in this case, a is x, so let's write x plus, and our expression for b is the number 3, so x plus 3. In the second set of parentheses, you're going to use x and 3 again, but this time you're going to subtract them. And that right there is our answer, or in other words, the factored version of x squared minus 9 using the difference of two squares formula. Let me give you another example just for good measure. Example 2. Let's do 16x squared minus 25y squared. All right, again, it's a binomial. This polynomial has two terms that are being subtracted. There's no GCF that we have to pull out from this one. And there's kind of a good sign that we'd have to factor this using a difference of two squares. First of all, notice that the variables x and y have a power of 2. And it would seem as though we could take a number and square it to get 16, as well as we could take a number and square it to get 25. So in the spirit of the last example, I'd like to do a little bit of rewriting so we can figure out what to use as our expression for a and what to use as our expression for b. Well, let's think about what we'd have to square in order to get 16x squared. Can you think of a number that when squared gives you 16? Right, that should be 4. Now in order to get x squared, we'll have to have x in there. So if we take 4x and we square it, we should get 16x squared. And I'll leave that for you to check. Now, let's think about what expression should be squared in order to get 25y squared. Well, if we want to think of a number that when squared gives us 25, that number would be 5. And in order to square something to get y squared, that something would have to be y. And so just like that, we rewrote the binomial as 4x quantity squared minus 5y quantity squared. Now doing it this way allows you to identify what expression you'll use for a and what expression you'll use for b. The expression for a is going to be 4x, and the expression for b is going to be 5y. All right, with that in mind, we can go ahead and apply the difference of two squares formula. Go ahead and set up two sets of parentheses right next to each other. And in the first set of parentheses, we're going to write a plus b, or in this case, 4x plus 5y. And in the second set of parentheses, we're going to write a minus b, or in this case, 4x minus 5y. And that takes care of it. That is the factored version of 16x squared minus 25y squared. Now, of course, you could check both of these answers by applying the FOIL technique, first, outer, inner, last. And after some simplification, what should happen is you should return back to the original problem. There's one more that I'd like to do. This one's going to be a little more complicated. I'm going to write it out as this. Quantity w plus 1 squared minus 49 p squared. All right, so this one is revved up just a tiny bit. Of course, the tall tail sign that is revved up a little bit is this quantity w plus 1 squared. All right, but then we also have minus 49p squared. First of all, this is kind of a binomial special case. All right, we're subtracting two terms here. No GCF, so we don't have to worry about pulling out any sort of GCF. There is a subtraction going on, and there are a couple powers of 2, so this does seem to resemble a difference of 2 squares. So if we're able to rewrite this as a squared minus b squared, then we're allowed to apply the difference of 2 squares formula in order to factor it. Well, let's just see about that. W plus 1 quantity squared is already written in a desired format. Let's leave it as w plus 1 quantity squared, and you'll see that w plus 1 is actually an expression for a. 49p squared, that does require a little bit of rewriting, and you can rewrite it as follows: 7p quantity squared. Now, having it this way allows us to see clearly what the expression for a is going to be, and as mentioned, that's going to be w plus 1. And now we can see clearly what the expression for b is, and in that case, it's 7p. All right, so a little bit different than the previous two problems, but we're still in a position to factor this using the difference of two squares formula. Now, with that said, let's open up two sets of parentheses. I'll make them a little bit larger to accommodate the expression for a. But in the first set of parentheses, it's going to be a plus b, or in this case, w plus 1, that's our expression for a, plus b, so that's going to be plus 7p. For our second set of parentheses, we write a minus b. Well, again, our expression for a is w plus 1, and we're going to subtract from that our expression for b, which is 7p. There we go. All right, so a little funky looking, but that is the factored version of w plus 1 quantity squared minus 49p squared. And we did that using the difference of two squares formula. All right, and that's where this video is going to end. If you have any questions about this, feel free to contact me and I'll be more than happy to help. Otherwise, thanks for watching and I'll see you in the next one.